Okay, welcome back everyone. We're going to be covering rationalizing denominators using conjugates for our irrational denominators, specifically like our surd-based denominators. We've got two questions we're going to do. The first one is 1 over 2 minus root 3. The second one is 2 over the square root of 7 minus the square root of 5. It is going to be the exact same technique for both questions. Part of why this skill is so important is it kind of ties in algebra alongside surd skills, alongside dealing with sort of like algebraic fractions. There's quite a lot of skills that go into this topic. It's part of why it's so popular for exams, and it's why it's so key to so many courses. Now, let's have a look at part A. I'm going to scroll down here a little bit. The first question we had was simply just rationalize the denominator for 1 over 2 minus the square root of 3. Now, the technique for how we solve questions like this, we need to hopefully remember a little bit of difference of two squares, which if we don't know, like I said, feel free to comment down below, and maybe I'll put a video of that on the channel at some point. But if we recognize the difference of two squares, we are trying to apply what we call the conjugate to create our difference of two squares. I'm going to change my color here to orange because I like orange. So if I create difference of two squares, we can think of this two terms on the bottom. We can kind of put that in brackets, right? I want to multiply this by, well, the exact same numbers, but instead of a plus in the middle, instead of this addition sign here, I'm going to change that to, instead of this subtraction sign, I should say, I'm going to change that to a plus. So I'm going to add root 3. Now the key here is numbers stay the same. Whatever my sign is in the middle, this part here and this part here, that is what's going to change. If it's a minus, it becomes a plus. If it's a plus, it becomes a minus. So once we've established this part, all we are going to do now is we are simply going to multiply both the bottom and the top by the exact same thing. That way we are balancing. I'm just going to multiply my numerator also by 2 plus the square root of 3. Now what happens is if I do FOIL and expand, I'll kind of show you what results we get. On the top, or on my numerator, I wind up with 2 plus the square root of 3, and I can put a 1 out the front of that just to keep it nice and simple. And on my denominator, if I expand out my terms, I get 2 multiplied by 2. That is going to give me an answer of 4. I also get 2 multiplied by the square root of 3. That is going to give me plus 2 root 3. And if I do my second terms, I might change my color to green here. I'm now going to do root 3, or negative root 3, I should say, right? We include the sign. We do negative root 3 multiplied by 2. That is going to give minus 2 root 3. And I also get the negative square root of 3 multiplied by the positive square root of 3. If I multiply the same square root, the square roots disappear, basically. The square root of 3 times the square root of 3 just gives 3. And I have a positive multiplied by a negative, so I'm left with negative 3. Now, the reason why we did the conjugate, if that wasn't clear at the beginning, why we care about the difference of two squares principle for a question like this, is what we notice is everything in the middle here for this question, that is a pen, let me get a highlighter, everything in the middle here for this type of question is going to cancel out, okay? I have positive 2 root 3, minus 2 root 3, that's going to become 0. So all I'm left with on the bottom of my fraction, on my denominator, let me just grab this here and make it a tiny bit smaller, that way I can kind of write in this final line, okay? What I wind up with as my denominator is simply just going to be, my numerator is going to stay as, you know, if I expand here and here, I get 1 times 2, that's going to become 2 plus the square root of 3. And on my denominator, I'm simply left with 4 minus 3, which hopefully most of us can see is going to equal 1. So I actually wind up with no denominator in this question. That is just a fluke though, it's not always going to turn out that way. And my final answer for my simplified conjugate, so to speak, is simply just 2 plus root 3. Now, a common question I get when I do an example like this to begin is, do I always wind up with basically the reciprocated conjugate for my answer, right? If we notice for my original question, I've colored it in highlighter. If I scroll up, my original question was 1 over 2 minus root 3. I'm left with 2 plus root 3. That's just kind of coincidental for this specific question. But this technique of basically multiplying by the conjugate will work for every single one of these rationalize the denominator questions, okay? I'm going to do one more. I'll do it a little bit quicker, and I won't do so much coloring, so hopefully it's a little bit less confusing to look back on. So, part B. Part B was, it was 2 over the square root of 7. I'm going to make it plus the square root of 5. The original question actually did have it as a minus, but I had a minus before, so I thought I may as well just show what happens if it's addition. Now, what I said was we use the exact same numbers. You know, I can put these little brackets here. I don't have to, but I can. And I'm going to multiply by the square root of 7. The sign here in the middle is going to change. It's a positive here, so it's going to become a negative over here. Okay, numbers stay the same, just swapping this sign here in the middle. again, whatever I do to the bottom of my fraction, I must also do to my numerator, that is the square root of 7 minus the square root of 5. And if I expand, there is a little bit of a shortcut or a bit of a trick for how I get to my answer. Okay, now for my numerator, I'm simply going to leave that as 2 outside of the square root of 7 minus the square root of 5. I would recommend against expanding. I'll show you why. And on my denominator, the shortcut answer, what we see before is because everything in the middle cancels out, what I'm actually left with is my first term squared. Well, the square root of 7 squared is just going to give 7. And I'm going to minus my second term squared. Well, the square root of 5 squared is simply going to give 5. Okay, so I can get to my answer a little bit quicker. Just to help explain that for those of us that are confused, if you have a look at this question here, the numbers that I am left with, and I know I'm doing a lot of color here, so I'll try to make this as neat as possible. The numbers I am left with is 4 minus 3. If I look at my original question, well, 2 squared is going to give 4, and the square root of 3 squared is going to give 3. I subtract the 2 terms. That pattern works for every single one of these questions. Okay, so if I use this pattern, square the first term, that becomes here, minus square my sort of second term in my difference of 2 squares, the square root of 5 squared gives 5. So if I tidy everything up, what I'm left with is 2 outside of the square root of 7 minus the square root of 5, all divided by 2. And this is why I recommend against expanding, because so often with these rationalize the denominator questions, we get something we can cancel. I can cancel out my 2 out the front of my brackets and my denominator of 2, giving a slightly neater answer of the square root of 7 minus the square root of 5, and that is where I would leave it. Now, oftentimes you do get fractional answers. I know the 2 examples I chose, both the denominators fully disappear. It's quite common with these questions, but also we can have fractional answers, and we're super happy with that as well. Okay, so hopefully you guys found this helpful. If you have any more questions about rationalizing denominators, feel free to comment them down below, and I'll see you guys in the next video.